Alright, in this video we're going over logarithmic function context and data modeling. Now specifically we're going to go over how to do this with a Desmos graphing calculator. There are plenty of other videos on how to use a Texas Instruments or some other handheld graphing calculator, but I want to show you how we can do this with a Desmos free online calculator. So to start with, remember, logarithmic functions have independent values, that is x values, that increase proportionally, while the dependent values increase at a constant rate. So if we look at this table, we see that our independent x values, they are increasing proportionately. We're multiplying by 3. Whereas our dependent, they are increasing at the same constant rate of adding 2. All right. Now, they also tell us down here that the amount the proportional values increase of the independent values would also be the base of the logarithm, which we'll get to. Now, for example 1, it says at the end of the school year, classroom gets really warm. As the number of students increase, so does the temperature. So we have this data. So the number of students goes up, 2, 4, 8, 16, and the temperature, 67, 68, 71, and 73. Now we want to write a regression equation to model this situation. So in Desmos, I click the plus sign and I add a table. So 2, 4, 8, 16 are going to be the x values that I type in. So 2, 4, 8, 16. Then in the second column, we have 67, 69, 71, 73. Now click the zoom fit so that I can see the points, and we can see that it curves downward, kind of like a normal log function will do. Now we want to use Desmos to give us what that regression equation would be. Now right now it's giving us a linear regression, so if I click the drop down, and I'm going to select logarithmic. Now we will always give it to us as log base e, using the natural logarithm. So we have 65 plus 2.88, 539 times ln of x. So according to this model, what is the temperature if there are 35 students? So that means we're going to substitute 35 in for x. 2.88, 539 times ln of 35. Now I'll just use the Desmos graphing calculator in line 2, 65 plus 2.88, 539 ln parentheses 35. So we predict with 35 students we're going to have about 75.2 degrees. Which makes sense because 35 is close to 32. And so it's just a little bit past it. So we're adding 2 to the y, so we're just going past 75. Now the second question asks, according to the model, how many students are there when the temperature reaches 85 degrees? Here, 85 is what's substituted in for y. So 85 equals 65 plus 2.88, 539 ln of x. So to get ln by itself, first we're going to subtract 65. So 20 equals 2.88, 539 ln of x. Then we'll divide 20 by 2.88, 539. And so in Desmos, that gives us 6.931 equals ln of x. So when we rewrite this, x is going to equal e to 6.931. So e raised to the 6.931. And so that's going to be 1,024 students if we round to the nearest whole number. Now, example 2, here, it says, Mr. Kelly loves to wake up and have a fresh cup of coffee. He likes his coffee to cool down before drinking it, so he makes a table of values to help him find an appropriate model. He sets his data up so that the time in minutes is a function of the temperature in degrees. If I look at time, time is down here. Normally time is the x value, but here we're not doing that. Here we're making time the dependent variable because it goes up by 3. So now if we go back up, now let's change these values in our table. So we have 95, 90.5, 86.5, 82, 78, 75, and then 0, 3, 6, 9, 12, and 15. Let's look at these dots. Here we go. So now we're going down this way. So as we write this regression equation, we can see that, okay, it has to be something that's probably close to logarithmic because it seems like we are multiplying by something. So if we were going to go with that, we'll do y equals 284 minus 62.369 ln of x. So this question asks, how long will it take for his morning coffee to be 70 degrees? Notice that it takes, the x value is the temperature. And the y value is going to give us the time. So y equals 284 minus 62.369 times ln of 70. So if I look at my graph, I see that about 70, it's 19.03 minutes. So that's about 19 minutes. So what's different about this graph is you actually read it from here and we go trace it up this way because time starts at 0 and goes upwards, just as the temperature goes down. So number 3, in this example, here, we're not doing a logarithmic regression. Instead, what we're doing is we're using logarithms to model sound. People measure loudness in terms of decibels using the following function, where d of I is the decibel level, I is the intensity of sound, and 10 to the negative 12 is the intensity of the quietest human sound a human can hear. So what is the intensity of the sound of the school fire alarm if it registers as 100 decibels? So 100 decibels goes right, whoops, doesn't go right there, goes right here. So 100 equals 10 log of I over 10 to the negative 12. So if I divide both sides by 10, we have 10 equals log of I over 10 to the negative 12. Now this is a common log, so when we rewrite this, we're going to raise both sides to the 10, and this will cancel, leaving 10 to the 10. I'm not going to write this as a number, and you'll see why in a second. We have I over 10 to the negative 12, and we're going to multiply by 10 to the negative 12, leaving us with 10 to the negative 2 equals our intensity of this sound. That's how loud that sound is. Now in example 4, Mr. Bruss wants to save for a new Lamborghini. He currently has $50,000 in an account that pays interest continuously, and he will need $300,000 in total. If he leaves his money in an account for 12 years and does not add anything, what interest rate would he need to achieve his goal? So we'll use this equation. The amount A is going to be $300,000. The amount that he starts with is $50,000, and we have E to the 12 t, because it's going to be in for 12 years. And so, sorry, not t, but r. And so it's the rate that we're solving for. So if we divide 50,000, we have 6 equals e to the 12r. So as rewritten with a logarithm, that's going to be ln of 6. Now don't forget your parentheses. Equals 12r. So r equals ln of 6 divided by 12. So if we compute that, ln of 6 and then divide by 12, we get our rate. Bring that back. And so that is 0.149.